Okay, so in class today, we did find, for this problem two, the last one in the 5.1.3 notes, we did find the equation for the complementary solution. And at first, I was concerned because I saw the cosine 2t, sine 2t here, and there's a cosine 2t and sine 2t there. But after class, Nazi correctly pointed out that this function doesn't repeat terms from the homogeneous solution because the cosine and sine in the homogeneous solution are being multiplied by e to the negative 2t. So this is a new function not represented in the homogeneous solution. So we're free to just use the guess and check method, but what I had on the notes, I was missing the 2 in front of the x prime. So this equation is okay. So it's going to change our a and b, but there should be a 2 right there. And so then if I equate coefficients of sine and cosine for sine, then I get negative 4a, and then I'd have 2 times negative 2b, so minus 4b, and then plus 5 times a, plus 5a equals, and the coefficient of sine over there is 3. And so if I simplify this, negative 4a plus 5a, so I just get a minus 4b equals 3. Or a equals 3 plus 4b. So now if I equate coefficients for cosine, so my first one is negative 4b, and then plus 2 times 2a, so plus 4a, and then 5 times b. And the coefficient of cosine on the right is 12. So I'm going to combine the b terms and substitute in for a. So negative 4b plus 5b is just b plus 4 times 3 plus 4b equals 12. And if we distribute through, I'd get b plus 12 plus 16b equals 12. Well, think we'd subtract 12 from both sides and they would cancel, and we get 17b equals 0. So that tells me that b is 0. And if b is 0, then a is 3. Which is actually nicer. So now this is not our solution. So we have x of t equals the complementary solution, which was e to the negative t over 2 c1 cosine 2t plus c2 sine of 2t plus, so the b is 0, the a is 3, and my guess, the a was the coefficient of sine, so plus 3 sine 2t. And now we want to use our initial conditions, which were, so it was released 1 foot below equilibrium, so x prime of 0 was 1. So that says 1 equals, so we would get e to the 0, which is 1, plus c1 times cosine of 0, which is 1, plus c2 times sine of 0, which is 0, plus 3 times 0, which is 0. So we get c1 equals 1. And then to find c2, well, we would have to use the product rule there to find c2 because we need to take the derivative of x. So x prime, here's our x. So I would have first times the derivative of the second. And the derivative of the second. So the derivative of cosine is negative sine, and I'm getting a 2 out in front. So negative 2c1 sine 2t. And the derivative of sine is positive cosine, and a 2 comes out in front, so plus 2c2 cosine of 2t. And normally I would close parentheses here. There's first times the derivative of the second, plus, and actually that c1 is 1, so you could use that, or we can plug it in later. So this was first times derivative of the second, plus the second times the derivative of the first. Well, the derivative of the first is going to be negative 1/2 e to the negative t over 2. So I'm just going to think of factoring out the e to the negative t over 2, but I'm still going to have minus 1/2 then times just what's in parentheses here. So c1 cosine 2t plus c2 sine 2t. And then the derivative of this is 6 cosine 2t. Extend this. And I'm not even going to worry about simplifying because I'm just going to plug in right now. Downward velocity of 5 feet per second, so that means x prime of 0 equals positive 5. I'm going to do it kind of in the space up here. I'll use a different color, so hopefully it sort of stands out. X prime of 0 equals 5 gives us 5 equals, so e to the 0 is just 1. So negative 2 times c1 times sine of 0. So that's just gone. Plus 2c2 times cosine 0. So I get 2c2 minus 1/2 times c1 cosine 0. Well, cosine of 0 is just 1. And c1 is 1. Plus c2 sine of 0 is 0. And then plus 6. Okay, so if I subtract 6 from both sides, I'd have negative 1. And then I add a half, so negative 1/2 equals 2c2. So c2 is negative 1/4. Okay, so I'm going to rewrite then the general or the solution using those solutions for C1 and C2. And it says, what is the amplitude of the steady state solution? Well, this right here, that's the transient solution. Because as t gets large, the e to the negative t over 2 gets really small. So this whole thing goes to 0 in the long run. And so then we're just left with this. This is the steady state solution. And the amplitude then is just the coefficient of sine. So the amplitude is 3. And then I think it was just, yeah, the only, let's see, let's look at the notes. Okay, find the equation of motion. Graph the transient and steady state solutions. The only reason I asked for amplitude was to choose a window on the graph, and then graph the equation of motion. The equation of motion is the whole solution, x of t. I've labeled the transient and steady state. So you can do this on your graphing calculator and then transfer. But I'll use a program called WinPlot, which is free and relatively easy to use. Make sure if you're on your graphing calculator that you're in radians mode for graphing this stuff. Okay, I was doing polar stuff and Calc 3. Okay, and let me check at the window I gave. So, well, I did -6 to 6 and then from 0 to 8. So I'm going to actually choose that same window here for graphing. So negative, oh, it was 0 to 8 for the x and -6 to 6 for the y. Oh, it has pi multiples. That's 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's fine. Okay, so I'm going to do which one they asked for first. Transient and steady state solutions on the same coordinate axes. Okay, so first I'll do transient. So I'm going to pause this and come back. Okay, so just like in your graphing calculator, I'm sorry, it has to be x's, not t's. But then, so here's the transient solution, and you can see that it starts out having those oscillations, but then they gradually kind of fizzle out. Okay, and then the steady state solution was just 3 sine of 2t. I have to use x's though, 3 times sine of 2x. Okay, and so now we see the steady state solution, and then we want to graph the equation of motion. So let's see. There's that one. There's the two of them together. And then the steady state solution is just the sum of those. I'm just going to edit this one and add 3 sine of 2x at the end. And I'll delete this one. So those two look very, very similar, especially like out here past 6, we see they both have the same minimum in about the same place. The x-intercepts are in about the same place. Maybe this one is a little bit farther to the right than in the equation of motion. The main difference is at the beginning here, where the blue graph started out at y equals 0, and this one starts up a little bit. But it gradually just kind of morphs into the blue graph almost. Okay, so that's it for the last part of the notes, and then I wanted to talk about what you'll see on WebAssign. Okay, I'm going to do them a little bit out of order here. But in problem 6, notice that they say find the steady state charge and the steady state current in this circuit. Well, the differential equation would just be, L d and then the second derivative of q. So I'm just going to write it with prime notation. Oops. And the L is just 1. So we'd have q double prime plus r times q prime, so plus 2q prime plus 1 over c. And if you do 1 over 0.125, you just get 8 equals 80 cosine t. So really, I sort of want to look at the homogeneous or the characteristic, complementary solution, just to make sure that 80 cosine or that cosine t isn't part of it. And so if I think of the characteristic equation, r squared plus 2r plus 8 equals 0, that won't factor, so I use the quadratic, and I get negative 2 plus or minus the square root of b squared, so that would be 4 minus 4ac all over 2. Well, this is the square root of negative 28. I can pull a 2 out, and then I would still have, because you can think of negative 28 as negative 1 times 4 times 7. So actually I would pull out a 2i, and then a root 7 would be left. So clearly this 80 cosine t is not going to be represented in the complementary solution. So we don't even have to deal with the complementary solution. All you have to do is find QP, and you just use the guess method. So A cosine t plus B sine t. So you don't even have to deal with any of this stuff. They only want you to find the particular solution. And then I is just whatever you find for Q, it's just the derivative of that. Okay. And then 4 and 5. So in 5, I'm going to do 4 last. In 5, so find the charge. So we'll get our second order differential equation, constant coefficients. And then it won't be hard to find Q of t. Your external force is just a constant, 300. This V is for the volts. So you'd have your equation equals 300. So you would just use the guess method, and your guess would be just a constant. So it's really going to be easy to find your particular solution. So you'll find your Q and your I, and when it says find the maximum charge on the capacitor, so charge is Q, and to find the maximum, so you'll take the derivative of Q, set it equal to 0, and it says actually just find the solution to 3 decimal places. Okay, so last problem is number 4. Okay, so let's set up this one. So these are all standard units, kilograms, newtons, meters. Those are standard, so you can go straight to the equation. So we have mx double prime plus beta x prime plus kx equals f of t. And they tell us the m is 4. And they say in the absence of damping, so absence of damping, that means beta is 0. So we don't have a middle term. And the spring constant is 64. And my f of t is 136 e to the negative 2t cosine 4t. So I want to get in standard form, so divide through by 4. So x double prime plus 16x, equals, let's see, 4 goes into 13 3 times with 1 left over, and 16 4 times. So if we're looking for the complementary solution, we'll set up the equation and we get r squared plus 16 equals 0. So we get r equals plus or minus 4i. So our alpha is 0, so our complementary solution is just c1 cosine 4t plus c2 sine 4t. And then we have to find our particular solution. So, and there's a cosine 4t, but here it's being multiplied by e to the negative 2t. Well, if you wanted to do the guess method, you would have to guess xp equals e to the negative 2t times a cosine 4t plus b sine 4t. And you could do that. It gets a little ugly. You could use maple. Let me bring it up quickly. You could define xp to be e to the negative 2 times t times, I'll just use a capital A, times cosine of 4 times t plus b times sine of 4 times t. And then I'm going to do xp1 for the first derivative. So xp1 is you just differentiate xp with respect to t. And you could simplify if you want. Maybe I'll just put that right in here. I don't know what it will do when it simplifies. Okay, it factored out the e to the negative 2t, which is nice. And then xp2 would be the second derivative. And so we would, I'll have it take the derivative of xp1, and then I also have that simplify command in there. So diff xp1 comma t. Okay, and so that's what we get. And then if we plug that back into the original differential, well, into the last form that we had, so once we got it in standard form, what we want is x double prime plus 16x. So we would do xp2, that's the second derivative, plus 16 times xp. And then, oops, simplify. And you can copy and paste, or you can use the percent sign. If you're getting something that seems weird when you use the percent sign, use copy and paste instead. So here, it collects all of the terms together. So the cosine terms, so we'd have a minus 4b. So we get a minus 4b has to equal 34. And then the sine terms, we would have, oh, there's a 4 in front of there. 4a, so that would be minus 16b. I missed that 4. I'll do it for the sine and then I'll fix that. So I'd have, for the sine terms, I'd have 4b plus 16a, and that's going to equal 0. Because there was no sign on the right hand side, so I need to multiply that by 4. So I'd have 4a minus 16b equals 34. And this, if I subtracted 16a from both sides, and then, so I'd get 4b equals negative 16a, and then divide both sides by 4, I'd get b equals negative 4a. And then plug that in here. So I'd have 4a minus 16 times negative 4a, so that would be plus 64a equals 34. So we'd have 68a equals 34. And then divide both sides by 68, so we'd get a is a half. And if a is a half, then b is negative 2. So you could do it that way. You can use Maple with the guess and check method, or you could use variation of parameters. So you have your, where's our complementary solution? There's your C1, and, or I'm sorry, your Y1 and your Y2. And so your Wronskian is just going to be, if you set it up and then with the derivatives, your Wronskian is just going to be 4. And then, so you'd set up your W1 and W2 and so on and finish like a variation of parameters problem. But I think if you go ahead and just use Maple, it's quicker to do it that way. So then and that's what we were asked to find, the equation of motion. Let's see, we would still have our C1 and C2. So x of t right now would be C1 cosine 4t plus C2 sine 4t plus e to the negative 2t times a was 1/2 cosine 4t minus 2 sine 4t. And then our initial conditions, where it comes to rest in the equilibrium position. So x of 0 is 0, that's because it was in the equilibrium position, and x prime of 0 is 0 because it comes to rest means the velocity is 0. So it should be easy to find one of these. X of 0 is 0 means we get 0 equals c1 times cosine of 0, which is just c1, plus c2 sine of 0, that's gone, plus e to the 0 is 1. 1 times 1/2 cosine of 0 minus 2 times sine of 0, which is 0. So c1 is negative 1/2. And then you'd have to take the derivative and solve for c2 and then just plug everything back in, and that's your equation of motion.